Good morning, all. Myself, Dr. Satish Deshmukh, working as a professor in a Trinity Academy of Engineering. I completed my PhD from VGTI Mumbai, and here I'm going to teach you fluid mechanics, introduction of fluid mechanics or fundamentals of fluid mechanics. When we think about the mechanics, when we heard the word mechanics, this is the analysis. Okay, in engineering mechanics, there is a analysis or effect of analysis of effect of force on a body when body is at a rest condition or that body is a rigid body. Similarly, in the fluid mechanics also, when we deal with the behavior of fluid, when force is acting on a fluid, when fluid is in a rest condition or in a motion condition, that analysis is called as a fluid mechanics. Okay. When fluid is at a rest, obviously it is a fluid statics, and when fluid is in a motion, it is a fluid dynamics. In a dynamics itself, again, there are two classifications, that is fluid kinematics and fluid dynamics. When we consider the force causing motion due to the action of force, okay, force is the one of the agent due to which there is a possibility of motion. Where this force is not considered in analysis, that is called as the fluid kinematics, and when this force is considered in analysis, that is the fluid dynamics. Means in a kinematics, there are parameters like displacement, velocity, and acceleration, and further so on. Some parameters are there. This analysis is called as a fluid kinematics. Whereas in a dynamics, we have to consider the all basic parameters like displacement, velocity, acceleration, as well as force causing motion. That is the dynamics. Okay. Again, there are further classifications of the fluid mechanics, but right now these are not in our scope or not in our syllabus. That is hydrodynamics, hydraulics. Okay, we have to study in a higher class. Then gas dynamics, aerodynamics, metallurgy, oceanography, hydrology. Okay. Before starting the detailed subject, what is meant by fluid? That is the first question. Okay. When we found the substances on a surface of Earth, maybe in a solid condition, or maybe in a liquid condition, or maybe in a gas condition. Okay. Or that state, we can say. Okay. When substance capable to flow, that is called as a fluid mechanics. Okay. Whereas when substance is not capable to flow, that is called as a static mechanics. Okay. In a static or in a is simple engineering mechanics, that body is a rigid body. Okay. When substance is capable to flow due to the deformation, that is called as a fluid mechanics. This is a simple definition of the fluid. What is meant by fluid? Okay. Okay, here this figure clearly give the brief information about the what is my fluid and why it is called as a fluid. Now see here there are two plates, and in between that rubber or deformed body is kept here. When force is acting on upper plate, okay, there is a possibility of deformation of this substance which is keeping in a between the two plates. Okay, so here this is the fluid. Okay, if there is a rigid body, there is no any deformation of that body, so that is not a fluid. Okay, this is the simple example of rubber given for explanation. Okay, there are two states of the fluid. Okay, as I mentioned it, where we found the fluid in a liquid state or in a gaseous state. Okay, in a liquid we required one specific size and shape of the shape container to keep that substance, or we can say fluid. And in a gases, again we require the container, but here upper surface of that substance is not fixed or not limited. Okay, because the particles are free in a gases, whereas in a liquid there is a force of attraction between the particles. That's why they occupy the size and shape of the container. But whereas in a gas condition, here particles are free; they are free to escape. Okay, force of attraction between the particles is very less or negligible. That's why we require the what do you say, that is the closure for the gases, similar to our gas cylinder in our house. Okay, there is a strong closure or wall. We can, it is said as a, called as a wall. Okay, then and then only we can compress that gas in that container. These are the two states, that is the liquid and gases. Now, what is the difference between these two? Okay, difficult to compress. Liquid is difficult to compress, whereas in the gases, it is easily compressed. We are daily use that our domestic gas, that is a compressed gas. Okay, liquid occupies the fixed volume, will take the shape of the container. But in a gases, because all the particles are the free particles, force of attraction between particles is less or negligible. That's why there is no any fixed volume. Okay, it depends on that vessel. When vessel is closed, okay, then we can say that is the size and shape of the gas. But without any closing of the vessel, we cannot say it is a fixed volume of the gas. Okay, that is the difference between these two. A free surface is formed. Yes, top surface is a free surface. Due to surface tension, we found the top layer or top line of the liquid when we keep in a container. Whereas in a gases, completely fill the vessel so that no free surface is formed. Okay. If there is no any closure, then that particles are escaped. Now, what are the applications of the fluid mechanics? Okay, fluid. We found the applications of fluid mechanics in a most in a daily life also, and most of the engineering branches like biomechanics, then household applications, then metrology, ocean engineering, mechanical engineering, civil engineering, obviously. Okay, that is the pollution, design of piping, flood control, transport of the river sediment, all these applications of the fluid. This is not a limited. Again, there are so many applications of the fluid mechanics in the civil engineering and particularly in mechanical. Similarly, in the chemical engineering, then again applications area of the fluid mechanics, that is the uh, military sector, then automobile sector, medicine, electronics, energy, oil and gas. All the examples are given in this one. Then some special applications like blood flow in a veins of the human body. Then swimming is again one of the application of the fluid mechanics. Pumps, fans, turbines, airplanes, ships, rivers, windmills, pipes, missiles. Okay, uh, in each and every these equipments or all these activities, there is the application of the fluid mechanics. Okay, in a picture it is shown, that is the missile aerodynamics. Okay, this is application of fluid mechanics. The automobile aerodynamics, size and shape of the our cars or vehicles. Okay, when we decide the size and shape of the car and vehicles, we have to refer the fluid mechanics. Okay, okay. Then high speed train. Okay, then wind turbine, smoke from the stack, pollution over cities. Okay, propeller, fans, centrifugal pumps, jet engine propeller, cross fans, cross flow fans. These are the applications. Ski jumping, golf, swimming, football, cycling. Then cricket. In cricket also there is a fluid mechanics. Okay, application of fluid mechanics. Then when we think about the classification of the fluid mechanics, okay, for a study purpose, this subject is classified in a uh, separate branches, or we can say sub branches of the fluid mechanics. Then when we classify this, first we have to think about the viscosity. Okay, viscosity is the main property of the or major property of the fluid mechanics which affect the on applications. Okay, actually viscosity is a resistance to flow. Okay, or we can say by virtue of it there is resistance is offered to the flow. Okay? That is called as a viscosity, and that viscosity is depend on the cohesive force between the molecules. Okay, Okay, so viscous and viscid uh, fluid flow. Okay. Then classification of fluid with respect to viscosity, that is a viscous and inviscid. So these are the some examples given. Then again, internal versus external flow. These are the classifications of the fluid mechanics. Then compress versus incompress. These are the different classifications of the fluid mechanics. Then laminar and turbulent flow. Okay, means here when viscosity is more, flow is laminar, and viscosity is less, then flow is turbulent. Okay, and how to determine, how to identify whether flow is laminar and turbulent, that is depend on Reynolds number. Okay, when Reynolds number is less than 2000, it is treated as a laminar flow, and if it is more than 4500, it is treated as a turbulent flow. Okay, Reynolds number is one of the dimensionless number. Okay, depend on, or it is determined by the basic properties of the fluid. Then natural, or we can say force flow. Natural means when rain drop on a surface of earth. Okay, it we can say this is a rainfall on the surface of earth. It is converted in a runoff after uh, that evaporation or other losses, subtracting the other losses. Then remaining is the runoff, and it is a flow on a surface of earth. Maybe sometimes in a subsurface of the earth. Okay, due to percolation, many times that flow is a subsurface. It is a natural. There is no any force applied for this motion. Okay, so it is called as a natural flow. Whereas a force, for example, when we install the pump for pumping the water from your well, supply well, and to the delivery point, we require the pumping. Okay, we require the mechanical, and we have to provide the mechanical energy to this flow. Then and then only flow is possible. That is called as a force flow. Then steady and unsteady flow. Okay, when you observe the flow in open channels, okay, many times we found the steady flow, and many times we found the unsteady flow. Steady means there is a no any change in the properties of the flow with respect to time. That is called as a steady. And if there is a change in the properties, the properties like where density, viscosity, surface tension, all these are the basic properties of the fluid. If there is a change, it is called as a unsteady. Okay. Then properties of the fluid. Now, fundamental properties, or we can say it is called as the primary properties, are very important in a fluid mechanics. Without these properties, we cannot deal with this subject. Okay. These properties, like first well-known property, that is the density, or it is also called as a mass density of the fluid. Okay, simply it is a ratio of the mass of the fluid to the volume of the fluid. Okay, as mass is, all of you know, mass is measured in a kg, whereas volume in a meter into meter, that is a meter cube. So we can say it's a unit is a kg per meter cube in a SI. Okay, and water is considered as a standard fluid in a fluid mechanics. That's why that the density of standard fluid, or the density of water, is considered for a determine the other properties of the other fluid or given fluids. Okay, and mass density of the water is 1000 kg per meter cube. Then specific weight or weight density. Okay, it is a ratio, or it is generally denoted by small w. Okay, or in many books it is denoted by uh, other names, or simply it is called as a specific gravity, or specific weight, that is SW also. Okay, or generally it is found as small w. So weight of fluid to the volume of fluid. Okay, ratio weight of fluid to the volume of fluid is called as a specific weight. Okay, as all of you know, what is the weight? According to Newton's second law, mass into acceleration. Okay, weight is the force. So what is the Newton's second law? That is a F is equal to ma. M, that is the mass into acceleration, but here acceleration is due to the gravity divided by volume. Okay, when we simplify this ratio or this equation, then mass of fluid into g divided by volume. Okay, okay, as per previous property, that is the mass density, that the mass upon volume is the rho, that is the mass density. So rho into g, so specific weight small w is equal to rho g, and this is one of the well-known relation, okay, between the specific gravity and weight density or specific weight. Then specific volume, it is a ratio of volume of fluid to the mass of fluid. Okay, it is a inverse of the mass density 1 upon rho. So obviously it's a, you can say it is a reciprocal of the mass density. So here it's a unit meter cube per kg. Specific gravity, this is also very important property. Okay, here ratio of weight density to the weight density of the standard fluid. Okay, in a previous slide I mentioned that standard fluid is the water. Water is treated as standard fluid whose specific gravity is 1000 kg per meter. Okay. So here simply for a specific gravity, as per definition, weight of weight density or only density we can say of given liquid to the weight density of the water. Okay. So easily you can determine the specific gravity of the given fluid. Okay, any given fluid. These are the specific gravities of the some substances or some fluids, we can say, that is the uh, mainly that specific gravity of the mercury is 13.6. That's why mercury is treated as a very heavier substance. Okay, that's why mercury is used in a manometer. Okay, when we think about the density of mercury, that is a if specific gravity is 13.6 into specific mass density of the standard fluid, that is a 1000. So its density is 13,600 kg per meter cube. Means in a 1 meter cube, suppose we have one box of 1 meter cube, 1 meter by 1 meter by 1 meter. Okay, length, width, and depth. When we fill the mercury in that box, it is found its weight is 13,600. Okay, that's why it is called as a heavier substance. Okay, these are the standard specific gravities. As this is the ratio of this mass density, so there is no any unit of this specific gravity. Okay, so water, given liquid is suppose water, that is 1000 kg per meter cube, and divided by standard liquid, again this is the water divided by 1000 kg per meter cube, 1000 divided by 1000, that is a 1. Okay, so it is unitless. Blood 1.05. Okay, when we see here, that is the mercury, that is 13.6. Okay, and gold, okay, gold is again heavier than the mercury, that is a 19.2. Okay, when we discuss some examples, basic examples or numericals on these fundamental properties or primary properties related to specific weight, density, specific gravity, this is one of the example. Calculate the specific weight, density, specific gravity of 1 liter of liquid which weighs 7 Newton. Okay, liquid is given, volume of liquid is given 1 liter, whereas its a weight is given 7 Newton. Where to determine the specific weight, density, and specific gravity? Now, volume of given liquid is 1 liter. So, okay, when we convert that, all of you remember this 1000 meter cube. Okay, now here, or simply in this way, that is the 1 liter is equal to 1 upon 1000 meter cube. Okay. weight is 7 Newton. Then specific gravity, specific weight upon volume, 7 divided by given volume, we get 7,000 Newton per meter cube is the answer. Density, that is rho, that is the specific weight divided by g, okay, acceleration due to gravity, that is 9.81. We get that answer 713.5 kg per meter cube. This is the density. Then specific gravity, that is the density of given liquid divided by density of water. Obviously, density of water is 1000. So your density of given liquid is the 713.5 divided by 1000. Okay, it is a 0.7135 is the answer. Okay, thank you. Today stop here. In the next topic, I discuss about the secondary properties of the fluid, that is the viscosity and other properties. Okay, thank you.